So when I read the thing, wanted to skip right to the solution because I more interested in how to you get the results, but the chapter does something right about measuring the quality of what you get, so to see whether what you achieve is any good or not, and that's actually much more important. So it's something which I want to get stronger at as well. So basically, what I see over here, we have a two data sets of text with summaries. So we have the CNN Daily Mail data set, and then at the end we use the Samsung data set where we have short discussions with a summary. Then we have a couple of models discussed over here, and then make an example overview of them, and they discuss summary metrics. Again, we have data sets, we have models, and we have metrics, and at the end, the chapter does a fine-tuning. So what we see about the data sets, one data set is news articles with summaries, and the other data set is short discussions, short dialogues with summaries themselves. The models which they're trained on, the baseline is just to take the first 3 sentences, which for news is a good baseline because news writers know that people start reading because they're interested and they stop reading after a few sentences. So the news writer knows that he has to put in the key points into the first 3 sentences to get the message over. So that's a good baseline. Then they have models, GPT-2, which basically GPT-2 and T5 are trained on many tasks. So that this includes summarizing. By GPT-2, you start the prompt with the text and write too long, didn't read, or TL semicolon DR at the end, and then you see what's the continuation, which should be usually conventionally a shortened summary. T5 starts with a question, sort of summarized colon, and just puts the text, and you get the result. And they have also BART and Pegasus, which are trained on summarization. I believe it's at least for Pegasus. And so the first part of the chapter uses these existing pre-trained models and runs summarization on them. So the technically what we do is just download the model, put in some input in the right format, gets their output. It's very, very, very simple. And the results are seen over here. And we see that most of the models produce quite good output, except for GPT-2, which has not been trained on text summarization, so it doesn't know what we want. Instead, it gives a summary of the most important characters, and as also pointed out, GPT-2 is hallucinating, doesn't know to produce true statements, just makes up some facts, like to say that Nestor is the fastest man in the world, which is sort of related to what is written in the text, but it's not true. So it doesn't try to do some. It doesn't have a notion of extracting sentences which should really be should be really true. It's just mix up some words. So GPT-2 over here, I would say, is the worst model for our purposes. And so the chapter takes one sample text and runs through this, all the programs and sees how the output looks. And if you want, we can look at the text in a moment if that is interesting. And then they say, well, let's make it more data scientisty. Take a test set and the metric and run it on a many, like 1,000 examples and see how well they work. So this comes up as a question: what is the right metric? Sort of how do you measure summarizing the text generalization, generated text? The problem being, there are two problems over here. One problem which is addressed by the metrics, another problem which is not addressed. One problem is that when you generate text, you have some freedom. So that if you, for instance, change the order of the sentence, usually often it's still a good sentence. So I can say I don't have an example here, but you can express the same statement in different ways. And if you would have a full match, 100% yes or no, then you would usually get not matching, even though it's a perfect result. So the metrics over here tries to look how similar the texts are to the given text. And I go into detail in a moment. The other problem is that you have different words to express the same outcome, the same statement. So you can say, I love something, I like something, I really think something is great. And there are different ways to express really the same meaning, but with different words. And the metrics which we look over here, I think, do not take these into account. I'm not 100% sure. Maybe they do. And if maybe you look at the metrics in more details, we check it ourselves whether this takes some multiple meanings into account. So let's look at the metrics. So the metrics basically are built. They have a matrix that is called BLUE and RAV. And I would say that basically metrics of precision and recall on n-grams. What does that mean? You have a ground truth sentence and you have a generated sentence, and you want to see how good is the generated sentence. So if you look at the precision, which BLUE is doing, you check which of these words or which of the n-grams, like the pairs of words or triples of words, which you have in the text are correct, meaning that they also occur in the true sense, in the goal which you want to have. So if all the words which you say are really in the ground truth, you say that your sentence is accurate. It's not claiming something which it shouldn't claim. I would say that is the basic idea, and it needs a lot of refinement. And so if you look for in BLUE, you look for accuracy or precision. You ask whether every word or every pair of words or triples of words, whether you find it in the correct answer. And if yes, you get some some points which will later add up in some way. And in the RAV metrics, you go the metric goes for recall, whether the words which are in the true sentence, whether they are appearing in the generated sentence. And I want in a moment to go more about the fine-tuning of these metrics, sort of how to make it more useful. But I want before that to say what's the difference between precision and recall. When you do translation, then people like the precision approach. They want to say that the sentences which are said are correct. They are within the realm of things which should be said, and approximately of the same length. So they should more or less cover the same thing. And we still go into this more. But if you want to summarization, then it's not enough that your words appear, so that the words are in line with what you're saying. You have a precision that the words which are generated are really what you expected, that they are expected in the output. But you want all the important words which are in the summary that they should appear. And if a word is missing, something which appears in the true summary and it's not in the generated summary, that's a problem. So they want something more like recall. So in the basic idea, basically we have take all the words and the precision focused BLUE metrics is asked
this word which appears in the general text, is it also in the ground truth? If yes, we have a plus. If not, no, we have a minus point. Whereas in the rough matrix, you ask whether all the words which are in the ground truth, whether you find them in the generated text. That's a basic idea. Now you do the same with n-grams. So you ask whether each pair of words appears according to precision or recall, each pair of words from the generated text, whether it appears in the ground truth or the other way around, if there was a pair of words in the ground truth is also found in the generated text, and so on, triples and quadruples. And then there are some fine pieces, for instance, for if you go for blue, for the precision matrix, you could just repeat one word over again all the time, and you get 100% precision, which is like cheating. And there's some penalty which stop that. You say you can't use, we don't count a word more than how often it really appears in the true sentence. If you see it more than it appears in the true sentence, then we don't count it towards you. And there's some other fine tunings to try to nudge these metrics to something, sort of to not to allow for some shortcuts or so on. So we have these metrics. They run the text through the metrics, and I don't know. We can look. The baseline has metrics of 0.39 and okay. They, I think they just look at one on Pegasus. Okay, they checked all the models on one example. They looked at one data set, full data set, and compared it on these metrics, but not all the models. They just evaluated Pegasus, and then they fine-tuned it. So for fine-tuning, they took a different data set. The first data set was news articles with the summary. The second data set is short discussions. And they did the fine-tuning. Now, the fine-tuning is, I believe, the standard fine-tuning for say sequence-to-sequence models, where you say this is the input text which we have, and this is the output text which you want to get, and fine-tune the model to produce this output. And there's something interesting step over here, which is, I think, called teacher forcing, which I can explain in a moment with a few words, which goes like this. Remember from the last meeting that in the text generation, you generate the text one token at a time. Let's ignore for the time being the complexity of beam search, but basically you produce one word, and after even within beam search, that is more complicated, you produce one word, and then you go to the, you take this as input and you continue to produce it. So if you know the true summary of a sentence of a text is, for instance, what a wonderful weather, and if the first token of the model is not what, then obviously all the outputs will be wrong. So that you will never get that the first token becomes right. So, so one way to train this model is to say you compute the first token, and if the first token is not what, you give the compute the penalty or the loss function according to what the real answer was. But then when you compute the next token, you don't take the token which the model produced as the input, you take the what as the input which the model should have produced in order to evaluate the next token. And then, and so on. So that the model is called always each run on the correct answer so far in order to produce the next token, and we evaluate it on that. And this sort of helps it to produce answers closer to the correct answer without searching for too much. There are trade-offs between these approaches, but over here that's just what they're doing. And they train the model, and they get some better metrics. Now that's my summary. That's just after reading the chapter for an hour. Now, I would be extremely happy if somebody has questions, either where I wasn't clear, or either where there are some points which we should want to go into it, and I didn't mention them.
Could you please explain teacher forcing again?
Okay. Tell me a sentence. Just I want to have an example of the ground truth. Any sentence. I just want to. Can you help me? Give me a
Yeah,
sentence.
Usain Bolt wins third gold of World Championship. So that's the sentence that I was reading from the book.
Okay, say it again slowly.
Usain Bolt wins third gold of World Championship.
Now I didn't get this. Type it in the chat. That's the best thing. Type it in the chat. Your sentence. I'm sorry.
Usain Bolt wins third medal.
Ah, that's from the text.
Yeah, from the text.
Bolt. Okay. Yes. That's right. So we should go with
There it is.
Okay.
Yeah.
Okay. So now let's play roles. I'm the teacher and you are the model. Okay. And you know your job is to generate text. How do you generate text? First, you get an empty. At any stage, you remember some words which you already said, and then you say the next word, and then you continue. So, for instance, if you were to produce a sentence, you would first say get this empty sentence in the case Usain. Then you know that what you said Usain, and now you say the next word is Bolt, and so on. Okay, so this is a way how the model creates word by word or token by token the output. So now when we train the model, we compare the words which you actually say against the words which we expect you to say, and we compute the loss function. Is that clear so far? Come on, so far I'm not saying anything new. I just put in the groundwork, sort of groundwork for the actual explanation of what the teacher forcing is going to be. But are we on the same page so far?
Yep.
Okay. So now what happens is if you have random or you don't know the right answer, so if you haven't yet been trained, because fine-tuning is training for a data set, you've never seen this data set before. So if I ask you, can you please, you get this full text, can you please summarize it? So your first word which you're saying is very likely not to be Usain, because you have no idea that this is word which I want you to tell. So you could say summarize a sentence, this text by something else. You can say World Championship, we produced some gold medals at the World Championship. Now, this may be a good sentence, but it's not related to the sentence which we want to hear you to say. So you say the sentence which you would the first word which you produce is World Championships, World Championship. And you say, well, that's not Usain. So I compute the loss metric for that and store for backpropagation in order to change the model to say Usain instead of World Championship. But now for the next word which you're producing, I'm not giving you the World Championship to continue your sentence, which would completely go off the direction. And I wouldn't compute error metrics based on the next word, which is completely different direction. I would say, now I tell you, you said Usain. I tell you the right sentence, and I ask, what is the next word which you say after saying Usain? And then you say Usain wins, and not Usain Bolt. So I say, well, we compute the error metrics according to wins versus Bolt, and we not the metrics, the loss function and the gradients, and we store them. And then I say, well, you actually said Usain Bolt, even if that's not what the model really said, in order to say what's the next word which you predict. Okay, now you say it's predict wins. So we say we have a perfect match and we don't have any errors. So we train the model word by word with the true sentence as input, what it said so far. And we measure the loss function for each new word. And so, which means we force the model to speak like the teacher. So that we always say, you said, or we pretend you said what the teacher would have said, what is the true answer, and now continue the sentence for one word. Was this clear, or did I overcomplicate it?
No, yeah, that's much better. Thanks.
I'm happy to try in a different way to explain it again, or maybe somebody else can say it in his own words. I think this is a teacher forcing is an important topic.
It's kind of a similarity from the metrics. If we look at it, uh, uh, the words that are uttering out of a teacher model should be close to the model of the student as much as it can be. That's the whole gist of it, which I got. Yeah, so those metrics should be equally be able to complete that sentence. Those teacher metrics should be able to complete that sentence without the student having much how do I say it? Yeah, I think we got it. I got it. Thanks.
So the major drawback, like for summarization, that I can see is you learn from example, from this specific example, but if you think about what would be a good summarization, putting it in a completely different order, if you paraphrase it, it would be right. This model would not learn to paraphrase at all, because it would learn to generate kind of the same sequence. And in reality, you can paraphrase it, right? Like, you know, in the world championship, third gold was won by Ocean Bolt. So this model would not learn to generate the second part of the sentence, the second variant. So if it didn't have a sequence, and the only loss was from overall generation, then it would learn to put things in different order.
By the way, GPT-3 is an amazing, amazing summarizer. If you threw that in this mix, it's almost a different story. And that's kind of what you just said, Yuri, right? Because that's just a generator. That's just a decoder. And it's just trained on next word. Doesn't use teacher forcing. Did I misunderstand you, Yuri?
Oh no, I was so Jakob said that there are like advantages or disadvantages for using teacher forcing.
Yes.
But I was thinking in this specific case, disadvantage is that it learns to generate sequence exactly like in the in the training set. But in reality, like paraphrasing would also work, right? So if you just had a score that would evaluate the whole sentence, but generated the whole sentence, not one word by word, then it would learn to generate paraphrased examples as answers as well.
I think you're opening a discussion, which is quite interesting over here, that when you do any machine learning, in particular deep learning, because of a couple of reasons of practicality, you do a lot of things which are not really perfect, but the best what we can do. So, for instance, okay, let's say I want to generalize what you said. You said that this teacher forcing is not really training to paraphrase, it's training to repeat the teacher. Sort of that if the teacher says something in a specific way, this is what we wanted the student to say. Now, the student can make a shortcut. He could say, well, the teacher is just summarizing the text, let me also summarize the text. And this is what we want to achieve. But really, the force the student to mimic the teacher, not really to summarize according to the metric. Now I want to say over here, let's take a slightly bigger picture. Let's say we have the example of we want to summarize conversations between customer representatives and customers, and we want to get the short summaries of all of them in order to improve our company's. We want to review and improve our company's response. Okay, so the real metrics that you want to improve is the bottom line of the company. We want to be more rich. We want to increase the customer retention and whatever. The first metrics is what you really want is we want to get more revenue. And then we say, well, we get more revenue by making our customers more happy. And then we say we get our customers more happy by making better summaries. And then we say we need to get better summaries. So we have a metrics over here which is based on recall and precision, which is different. We just say we want to get the same words, but maybe in different order. And then we say, let's force the model to say exactly the same words as we said before. So we, at each step, exchange one metric for another metric until we get to something which the model can work with. And we hope that by optimizing the last metric to push the model to work like the teacher said, exactly the same words, that in the end, the first metrics, our company will be more rich by everything in the middle works through. And sometimes it works and sometimes not. And I want to say, why do we do that? Why don't we take as a metric the bottom line of the company? Let's optimize straight to the bottom line of the company and everybody would be happy. And the point is we can't do that because A, we can't measure the bottom line of the company so quickly as we need, and B, it's not differentiable. And if it's not differentiable, you can't do back propagation. So at each step when we change the metrics, we do this for specific reasons that say that we have a matrix which can be measured in a much more short time. We have a matrix which can be computed immediately. We have a train set or a test set for that. And for deep learning, we always need something which is differentiable. So the metrics over here, which we have, the rough metrics and the blue metrics, they are not differentiable. So if you can't use them for deep learning as they are. You can only use them for evaluation. And as a result, the model actually doesn't know what you want. The model doesn't know. You never tell the model that you want this, the real metrics. We only hope that by giving him enough examples and say the same words as the teacher, that maybe he picks up something which helps with these metrics as well. And this is a common problem with any deep learning. So if you do any deep learning, you always do this. You train the model on something else. The model doesn't really know what you really want to achieve. And you hope that by giving it some differentiable metric with good examples, that it will guess, it will feel out the right metrics which you want, but may or may not work. And this mismatch between each stage is something which is sort of keeping data scientists sort of up at night to see, well, did I really use the right way to represent this, what I really want? And if the data scientist doesn't care about it enough, then he may easily get a model which is perfect on the training metrics which he has. So if he exactly says what the teacher said, because this is what he taught him, but he doesn't care about the other metrics which you have because he didn't tell him. And then your whole pipeline at some point fails to generate value. And this is sort of a problem for all deep learning applications.
Yeah, that makes sense. It's an interesting way to see it. So I've got a question then with what Yuri brought up, which is, so what are the alternative loss mechanisms to teacher forcing when it comes to summarization. That's still not going to be perfect, but that would be more towards paraphrasing, perhaps, as Yuri says. Are there alternatives to teacher forcing that are used that anyone knows of?
I think so. Scheduled sampling is one technique that takes out tokens. So that might be one alternative.
Well, I'm sorry. What was it called again?
Scheduled sampling. Scheduled sampling. That might be one alternative to teacher forcing of training your models so that it half finishes the sentence that is trying to train and then picks it up, like the tokens that we are trying to predict in the teacher forcing method. So if you type on Google teacher forcing versus scheduled sampling, that's kind of like the two major school of thoughts that were popular in the 90s in I think so 2010s when this paper came out. So I'm just trying to read it. I will try to share the link of the paper.
Can you share it in the Slack channels that we keep it for later?
Yep. Yeah.
But I have a question, Yuri. While I can grant that, teacher forcing provides, at the end of the day, teacher forcing, what it's doing is it's narrowing the conditional probability of the next word that's chosen by providing feedback of the current word. So, for example, if Usain is the first word that the model generates, then that the decoder generates, then it's going to say, oh, for the next word, use Usain also along with everything else you got from the encoder. And then therefore the model will conditionally generate something which includes from the decoder the token for Usain in addition to anything else from the encoder that it was already using. But it does not, in my mind, constrain it to only produce whatever in the text it was, whatever in the text was the token that follows Usain, because it still takes all of the encoder tokens into consideration in generating the next token. So the token for Bolt, the probability for Bolt as the next token that the decoder generates is increased by the fact that it now factors in the token for Usain, but it also has the model for the decoder still has to consider all of the tokens from the encoder that came into it. And therefore, while it increases the probability of the token for Bolt being chosen, it's not a certainty. Therefore, I don't think, at least my understanding of it doesn't say just because you teacher force does not mean that the decoder model will generate the exact sentence from your text that starts with Usain, because the text has its own thing, but the model has internalized the text through the encoder, and the only thing we are additionally doing between using teacher forcing and not using teacher forcing is we are telling the model at each step as it generates the decoder model, as it generates each word, right, that, oh, this is the prior word that here is the word that you generated. Hussein and as the prior word. And now I'm going to also give that to you as an input in addition to all of the context you have from the encoder.
Yes.
So,
I'm not sure that...
so the question is, theoretically, it shouldn't be really fully limiting paraphrasing. There should be some paraphrasing. So I'm wondering, Yuri, are you coming from a theoretical point of view? Or are you really coming from the fact that maybe you've done some summarization with different things and you found that teacher forcing produces too narrow of a unparaphrased summary?
No, you guys putting too much into this question. I was, Yakov said that there are positive and negative things on teacher forcing, and I was like, because I saw that the paraphrasing wouldn't work, I thought maybe that's a negative thing in this.
I want to give some background over here. First of all, the question is an excellent question. Second of all, it's not only for summarization, but it's true for every text generation. Sort of also, if you want to have translation and so on, the same questions arises. How do we train? And I remembered to read something about teacher forcing, and I remember there have been some alternatives, and I forgot them. So the only thing which I remember from them was actually how teacher forcing works, and so I was making it up. And you just pointed out where I forgot some alternatives. And when you asked the question, I was really happy that somebody asked the question. I hope that somebody would answer it. And so we got a good answer over here. So I have to read up on the scheduled sampling after the call. So thank you very much for following up on me sort of brushing over some important pieces.
I think the T5 is trained on teacher forcing.
Mm-hmm.
Yeah.
I just posted just something I had found when reading, which is a benchmark for abstractive text summarization. You could see that there's a new model out that
now
Brio, yeah.
I suggest when you put up some background material, put it on the Slack channel and not only in the chat, because in Slack it will be there for after the call. If we finish the call, the chat will be gone. I believe. I'm not sure.
Done. Fair now. Which is interesting because I was just wondering if there was newer, and yeah, Brio is a new on the same set that we're looking at in this book, BRIO. You'll see if you go to that link. Is winning. Are there other questions like that are more technical? As well, about clarifying anything in the chapter?
Well, there are the chat questions which came up that the notebook doesn't run for two problems. One problem is that the code puts part of the data on the GPU and part on the CPU, and then it doesn't work. And I would be very happy if there would be a solution for that, the clarification of what happens over here. And there's a problem is also that on in Colab, that just broke some of the libraries so that you can't log into Hugging Face anymore. So hopefully that fixes as well. But maybe that's not the technical problems which you technical questions which you ask for. I think you ask for technical questions.
No, that's fine. No, that's fine. That's fine. So did anyone have any? That's important. Did anybody? I know Srinivas, you posted maybe about that. Is anyone figuring anything out?
Yeah, but actually, to Mayank's point, my TQDM continues to work fine. So it isn't TQDM related, but it's specifically related to the, and I was able to log into Hugging Face from Colab, which I was able to do for the other notebooks as well. In this case, and I haven't had the right time to play around and try to fix it. Obviously, one of the fixes suggested is to just run it on CPU, but that doesn't work given the size of the model, so it'll take too long. The other fix from the PyTorch pointer search that I did was to say, oh, you then, there's some issue with the encoder, because this is an encoder-decoder model, Pegasus, that finally we are working with towards the end of the notebook. And it says, oh, there is some code you can do on the encoder side, where if you have multiple encoders stacked, sometimes there's a problem, and here is something that you can do. And in fact, the PyTorch expert chimes in on that thread I posted and says, I don't think why this should be happening, but here's a fix. And the problem with that is, obviously we are using a Pegasus pre-trained model or auto language model, blah, 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 for sequencing. So it's not like I can go into the encoder. I mean, you could, but then you'd have to download the model and futz with it and then train that model, because this is a pre-trained model we're using. So seem to be stuck at that point with neither of the solutions being practical. So that's why I was asking whether anybody has successfully managed to run it to the very end, and I didn't see.
Is a fix to
replace?
Does a fix really change the algorithm of the encoder, or is it just adding the lines to put it on the GPU?
No, it wasn't to device. It was something which says, because if you see the error I posted, and that's the exact error to which the the response was, put something like the wrapped model to device for encoder in wrap model.prompt encoders. And I'm like, that's, and then encoder dot to device. But I tried the model to device, simple change, but that continued to give the error. So it's something more specific than that. And, again, sometimes in Colab, it so happens that you hit a situation that, they are changing something and something goes wrong. So I want to try the whole notebook one more time before maybe post it as an error on the GitHub for their notebooks and stuff, unless somebody tells me that they have successfully run it to the very end. I didn't see anybody tell me that.
I tried to run it,
which is why I
wanted the same error. On Colab, I run into the same errors as you said. So they have exactly the same error.
Oh, okay. Okay. So it seems like
on which cell, Sri, you ran into that error? In the second last cell, or somewhere in the middle?
Train.
No, it is when you try to train the Pegasus model on the Samson dataset. It's the cell which says trainer.train after you have defined the trainer and after you've logged into the Hugging Face hub from your notebook. Then you try to train the model or fine tune the model for the Samson, which is the conversation data set. It's the second data set that you was talking about. And when you train the model, then it throws the error at that point and says that it expects all the tensors to be on the same device, but found at least two devices, blah, blah, blah.
Yep. No, I had the problem of those Colab is acting weird right now since yesterday. So yeah, I wasn't able to, but I will post it as soon as they fix it and we are able to run it in one sequence in one go.
Okay, that's the cell which doesn't work, which I have highlighted on the screen.
Exactly.
And this cell also doesn't work.
Yep.
Because now you can have a workaround to this cell if you set this true to false and skip this cell, then it works, because this cell is just needed for the push to the hub. If you don't push to the hub, then we can still run the model, the training, without being affected by this.
Okay, cool.
Okay. Any more questions?
I do. Does anyone have any experience, practical experience? I'm curious what the context was for doing summarization, how you did it, and also if you actually used a metric like Blue or Rouge, or how you judge the results. Yeah, I guess whether, I mean, ideally it would be something that was a real practical thing that you did for a customer at work, but even if you just did it for a personal project or anything. Does anyone have experience I want to share with summarization?
I remember that you said that you tried it on recursive summarization for really large text, and you were surprised how GPT-3 works well. But that's you
Well,
should
David,
say
yeah, but there's a guy named David Shapiro who's on YouTube that does some amazing stuff with GPT-3. And he took out, I watched a video of him. I've used it for summarization as well, but I watched a video of him where he takes Alice in Wonderland and he chunks it into the biggest size that the model will take. And then no intelligence to the chunking. He just chunks the text, breaks it into chunks that can be consumed by GPT-3. And then he takes all of the chunks, I don't know how many there are, that make up the whole thing, and then summarizes each one of those. And then that becomes the new text. And then he chunks that up and he keeps going. And he actually does it all the way, fewer and fewer chunks each time. It's recursive summarization. He ends up doing a 1-sentence summary at the end. But it definitely showed the power of recursive summarization. So that was fun, of course. But so of course, I gotta tell you, GPT-3 is amazing at it. It's slow and it can cost money, but maybe Bloom will eventually get good enough. That new, it's on Hugging Face, the new GPT-based model. It's there, but it also solves, of course, the limitations of the BERT models and stuff with length. Is one way is by doing a summarization and getting it down to the size you need for it to consume.
Are you using GPT-3 yourself?
Yeah.
A few questions. What API do you use, and how expensive is it for?
Sure. I use OpenAI. Cohere's cheaper, but the reason I use OpenAI because their GPT-3 DaVinci, which is they call it their Instruct model, is, as far as I know, it's a head and shoulders above the others. I mean, Cohere's pretty good. Cohere's pretty good, but that if I would suggest always starting. It's cheap when you're doing one-offs and learning. I mean, so far I haven't spent more than $30 in a month. Okay, and that's expensive to work, but I'm not running. I'm learning and like doing small numbers of things to try to get it to do what I want it. So I'm not running it programmatically on 100,000 documents or anything. But that OpenAI API, if they have an API, it's very easy to use. You sign up, it costs, it's based on how many characters total for the prompt and the completion. It's very inexpensive to play with. I highly encourage people to do it. And there's an API, so I'm using their, so that's it. The DaVinci, the most recent OpenAI model, DaVinci.
Now, if I want to just run 1,000 examples, could I still pay with about $30 or $100, or is that already too much?
I would guess that might be right. I don't know. It depends on how many characters you're talking about, but you'll get a feel for it. There's like no risk to playing with it.
Sure.
And you'll get a feel for it. And then there's a way to calculate that kind of thing, and you can make calculations. So, but
you said you spent $30 per month. You typed in every character yourself to make up these $30.
No. I also I'm also running things programmatically on a small scale. So like yesterday I ran, these are not for summarization. I use it for other things, but I ran, like I'll run like 10 processes, and each one of those uses GPT-3 like 3 times, and it's not a huge amount of text, but one of them has a whole part of the prompt is a whole web page text from like a company's product page. So I'm running, I run, like programmatically 10, 20 at a time. Yeah. So anyway, does anyone have any? I'd be glad to talk more about GPT-3, in other contexts as well. But does anyone have any experience they want to share with summarization? Because this opened up my mind to all these different models that are specific to summarization, and I could see how, obviously I'm a huge fan of GPT-3, but these are much more convenient and inexpensive, and maybe they have different sort of characteristics you can take advantage of. So I don't know.
I agree with the question. Don't have an answer myself. So
You're interested in the question too. Yeah. So I do remember when everything was abstractive versus extractive. So I don't know if anybody would why in this world of abstractive summary being effective would anybody want to do extractive? That's another question I have.
Say it again. You say, what is? I understand the difference between abstractive and extractive, but what's your question again?
Well, abstractive is so good and fluid nowadays, and covers the semantic content so well of what you're trying to summarize. Why would you want to do extractive? I mean, I feel like extractive just comes from the old days when there was no such thing as abstractive. So that's another question in my mind. And the reason I ask it is because maybe there's particular use cases where extractive really is still quite valuable. And then I'll throw another, just while I'm brainstorming my questions I have about summarization. Another question is, with blue and rouge, I know we're using grams, n-grams, words or whatever, but why not calculate the semantic similarity? Either through, instead of n-grams, extracted, keywords, or rather, like when you use GPT-3 to get keywords, they don't have to be in the text itself. So in other words, you could use vector representation, right? So why not take the full text and you put it into dimensions, the same dimensions, and take, that's what you do with semantic similarity. So why aren't they using, even though they're different sizes, you can put them into the same semantic space. And then why not use that as a measure on top of these other ones? Because when I think about it intuitively, right, what I want to do is say, not use the same words. I want to say what the big text was saying, but in a smaller space, in fewer words. So then I want to know, with those fewer words, did it cover the meaning of the first one? And that's how a human judges it, I would think. And this is obviously not hard to think of, this idea, right, of doing semantic similarity. So maybe it just doesn't work very well.
Okay, first of all, I had the same question in my mind when I read the chapter, and I can tell you what my mind told me justifying the current state of affairs. Okay. First of all, I tell you my take on both of your questions, but it's not okay. Extractive summarization is simpler than abstractive. And so the thing is that once if you don't have the capability to do abstractive, going for the extractive is easier. So there's a smaller step. And I would think that if you can do good abstractive summary, it's always better. But maybe to have a cheaper model, sort of if you have the choice between GPT-3 doing it for you, perfect work, abstractive, and you have another model which you can put on a smartphone and it does the well enough job, maybe you go for the well enough job at a cheaper price and it's good enough abstractive. So I think the trade-off over here, as far as I see, is that extractive is cheaper, easier to control, it's better understood, and easier to get right at. Now, the second question, I give you a similar answer. I think that if you do some vector similarity between the I think you suggested two different things. I had you two things. One is to take the vector similarity between the generated answer and the ground truth, what should be the right answer. Or you could say takes the vector similarity between the right answer and the text, or the general text answer and the text. So I just want only to talk about the first of the two examples, where I say takes, instead of the blue matrix or the rough matrix, takes the vector similarity between the ground truth and the generated text. To me, it sounds like an excellent idea with quite some technical problems. So what does it mean? That somebody, maybe you, maybe somebody else, actually has to do it and work out all the details. So that I think that if you just put it up, you just copy paste some code and you run it, it probably works, but not good. So that if you will run into quality issues, and if you take the time to work them through, maybe you have another paper which opens up a new generation of how to do summarization, but it's work which you have to do. Now I see over here a problem is that these two metrics based on recall and precision, you can fully understand them and you can double check them easily so that they are easy to control. When you have a vector similarity, you introduce a different model over here. So what model do you take for vector similarity? And if that model isn't good, then your measurements are affected by that. So you have you have many more moving pieces over here which make it difficult to do. But on the other hand, I think because it could say that a vector model of a text, I'm not sure. No, I think that to me, it seems to me a more difficult but better idea. So if you would take like a half a year of your time and actually do it, and maybe then afterwards all the world goes in the same direction because it works. But somebody has to put in the work to make it work.
Yeah, I mean, maybe it adds nothing to Blue and Rouge anyway. Not worth doing because you're using the grams and you're being very, those carry the meaning, and especially because we're using transformers, so they're contextual. They even have the contextual meaning. You don't have to worry about word sense disambiguation or things like that. So maybe it would add very little to what the numbers from Blue and Rouge are really telling you anyway.
Now, if you go in this way that you say that I have a good idea, and then you say, well, it's difficult to say, maybe it doesn't help enough, and I don't do it.
Yeah,
that's stealing the world of a potential breakthrough in summarization techniques. So I don't agree on that. But we don't know until somebody tries it out and sees what works and not. That's now I think one thing over here is when you do data science, I think so far the talks which we had were very straightforward. We say I have a good idea and we just do it, and we see that we get good results and it all makes sense. But really, data science with deep learning is where you say, well, I want to get something and I have something else, which doesn't really fit the one into the other. And maybe if I do something which is not 100% right, maybe it works. And I try. And sometimes it works, and then you're happy, and sometimes it doesn't work, and you're not happy. And so this kind of this is a sort of not really a logical approach, or as we say that I deduce from a problem a solution. You just try different ideas, but they are not 100% correct. And then you see a problem. For instance, in the blue matrix, let's take precision of words, and then they say, well, the model cheats. It always says z. The is the most important, most frequent word in English, and you just win all the precision text by always saying the because it's mostly right. So they had to introduce a penalty to stop that, and then they had to make another fix until they got something which is good enough to work with. So I think that if you put in the same amount of this is in all of the deep learning, you have to do that. You have to come up with some idea. Maybe it works, and if it doesn't work, you have to get another idea. And I would be very interested in sort of hearing these trade-offs of sort of besides the success stories, what works, what are the problems which you need to take into account, sort of where do things go wrong, and how do you debug the quality problems. That's something, but sort of maybe I should learn myself and teach that. But that's something which I'm very interested in hearing.
Well, we should do on the NLP embeddings call that we have every week. I should find a summarization person who does that in their work and for a living, and then we could, that's what we do on that. Sometimes we bring people in have a lot of experience, practical experience. So, but anyway, I'd be interested in that too. If you come across somebody, let me know. Maybe I'll reach out to them, see if they'll come on this and talk summarization too. So.
Any more questions? Any more comments?
Yeah, along the lines of what we were discussing on the metrics, other than the fact that the blue metric is kind of, one of the differences that they talk about in the book as well between the blue and the roads is the fact that the blue metric sticks with just precision, whereas rogue, while it starts off with recall, they say at the very end, oh, but recall just doesn't work, so we throw in the precision and it's almost like an F1 score.
Oh, but, I was just thinking about that. Thank you. Yeah, that connects.
And, it's not, on the other hand, other than the fact, like you were saying, that, blue scores have tended to work for translation and for summarization maybe, and maybe somebody tried the adding recall to it and it did not help. There's not a good explanation of why adding recall to that metric also is not attempted, other than the fact that we assume it's not explained, or at least in this text, why the blue score doesn't also have a recall element to it, whereas the rogue score does. And at the very end of all the discussion of rogue, they just say, but in practice, we find that only sticking to recall is still a problem for rogue, so we throw in precision as well, or a version of it. And
it's probably historical, right, Srinivas? Because blue's been around a while. You still have to keep using it.
Yeah.
So that's a really interesting point.
But then, but to your point, Darren, if blue version with recall is consistently better, people would have switched to it with reporting multiple score, like blue with recall and blue, traditional blue. But I've never seen a blue with recall. So it just means that practically adding recall to that doesn't seem to give anything better than historic blue. And my question is more like,
why? Yes.
I'm sorry.
I tell you what. Shall I tell you what I understood from the text? I think of the text did relate to your question, I believe. Okay. What I understood is that the blue matrix has been used primarily, or has been developed for translation. And the rough matrix is, say, needed for summarization. And I think there's a different need between translation and summarization. Now, in translation, if you take a transformer model which is trained with which has a language model, so it knows how to speak, and you get it to say correct words, but not all the words which are in the text, but you still get the similar length. So if you say sentence, that you say, you have to write the sentence as 7 words, and you nudge with the magic the sentence to also the same 7 number, and you want to have the precision, you somehow have you have to fill up the 7 words with right words. So if they are okay, let me start again. I'm saying the text said that for translation, precision is more important than recall, and it seems to work. And in particular, if you also control for the length of the sentence. And for summarization, that's not good enough. And so the answer was that they tried, say, to use recall for translation. They saw that recall for translation is not good, because if you say paraphrase, or if you use a different word, you punish twice. So you say this word that this word doesn't appear in the input text, in the ground truth, and also you say that word which is in the ground truth, you don't find it. So, and this double penalty for translation is not, people see that it's enough to be precise. By us, for summarization, you want to make sure that all the important points are covered. So my answer to your question is, why did they put in recall into the metrics? Why didn't it help? And what I read from the text is that for translation, they tried and they see that for translation it doesn't help. And translation doesn't need the recall. Translation more needs the precision. And I would guess that you get recall anyhow, because that if you have sort of the only words which can help you for good precision are the right words. So that if you don't use the right words, if you have zero recall, you also can't have any good precision. But sort of the point is that if you miss some words, then that's not such a big problem with translation. Is that what I understood? And sort of that when people need the recall and blue isn't the right metrics, they use rough, or they create a new metrics. But for translation is a big enough use case that you don't change the metrics, that it's no longer good for translation. You just have to make a new metrics for that. Did I? I'm not sure whether I answered you.
Yeah, no, I think that explains what you're saying with respect to not using recall for translation, and sticking with just precision, which they explained, as you said, in the last paragraph. But the question to me more was, after explaining how in summarization, recall is more important, then in one word, they just say, oh, but in practice, eliminating precision did not give good results with Rogue. So we also bring in an element of precision.
What's the problem?
Which is kind of what they say towards the end, right? That
I think it just explains the idea. I think what they did in the book, they say, first of all, let's explain the blue metrics in depth. Let's explain the blue metrics in depth with the motivation for translation. Then they explain the recall-based metric and go into depth of the recall. And then you say, well, that's not enough. You need to do this. But because we already covered it, it just comes out one sentence. Because we just say, well, take all what we have over there, put it together in the package, and it works out. I think it's a pedagogical thing that you choose what to spend more time on explaining in the book, and what ideas you just mention with half a sentence, either because the reader already knows or because you decide not to explain it. So my point is here. So if your point is 100% correct, but the length of how much the book explains it is not really indicative of the importance. It's just a decision by the book, pedagogically, what to explain, what to not explain, or what to skip over. I think I lost the connection. Are you still there?
No, I think, what threw me was, and of course, I think the answer lies in probably few papers between when the original Rogue proposal came out, because what they say is they give the formula and then they say, this was the original proposal for Rogue. That's the line immediately following the Rogue end metric. And then they say, subsequently, researchers found that fully removing precision can have strong negative side effects. So I think what I'm missing, or probably if I, look at papers between the original Rogue proposal and then, as usual, people responding to it or critiquing it, I'll probably get the reasons, and there'll be discussions, more in-depth discussions of why the original proposal for Rogue was modified in order to add in precision. I think that will do the trick.
You're asking what are the strong you're saying what are the strong negative effects, and
Yeah,
for
and I think
for blues it says the strong negative effect is that you just say the word the all the time, and you get 100% precision. And over here the text doesn't go into the details because probably it would makes the book more longer, so it's a decision not to go
yeah,
into
it may not be that important, and anyway, it's empirical in general. So as Erin was saying, so we just skipped it. But if I wanted to, I guess that would be the source of why they added or why they modified the original proposal.
Yeah, I agree. Yeah.
What I can say about the book, I'm very values their decisions what to explain, what not to explain, because sort of just reading the book gives such a good insight, and their decisions sort of if they would put all the information in here, we would just get an encyclopedia, and it's like reading a lot of blog posts, which would you confuse you. And if you just have an overview, then you don't get any hands-on knowledge. But I think one of the quality of the book is, which I really value, is that they make a tough decision. Let's say, well, there's some very important piece of information over here, but we don't tell it because we want to make it short. And over here, we tell it because it helps the people understand. And so, so if I want to say that there are many places where I wonder sort of how they decided, but in many cases I see that the decisions of sort of what to include and what not to include is very pedagogical and helpful. Sort of, I regard this book very high for making these decisions. But it's truly a pedagogical decision. Sort of, if you're interested in what's the right answer, you have to expand over here and you have to search in the web and to go into that. Shall we?
Do we have somebody who's interested in next week? What is it next week? Question and answer?
Yes. I was considering to do that, but I'm not sure whether I have enough time to prepare it.
Does anyone else have a keen interest in question and answer?
I'm happy to present it if nobody else wants to take it, I'm happy to present it, and if so, I would be happy if other people also read the text in case that I'm not making the full picture, so that people fill in the gaps. I'm quite in the next. I thought about the next chapter. Sort of the points where I'm strong is about what is the solution, but a lot of the chapter talks about measuring, and there I am not sure how well I understand that sort of evaluation of the models, and so maybe on that that's where I'm more flaky for the time being.
Yeah. Okay, sounds good. Is there anything anyone else wants to bring up, or any administrative things or anything at all before we call it a call? All right.
So I put my name in for next week, and anybody who wants to help out will be very happy to. And if somebody wants to take the full chapter, I'm also happy with that.
Excellent. Thank you. That's good. Yeah, Tasha. Appreciate it. All right, guys. Talk to y'all later.
Bye-bye.
Take it easy.
Cheers.
Bye.
Cheers, guys.